Tomorrow will be better. Waves hit a beach every 3 seconds. The horizontal distance between an adjacent maximum and minimum is 1 meter. Find the wave speed in meters per second. Follow me, dear friends. Solution. Let's start by recalling the expression or the formula for wave speed, which is V equals to lambda f. In this formula, dear friends, lambda represents the wavelength and f the frequency. Some will say, but none of these quantities have been given in this question. But dear friends, if we read between the lines, we will notice that all these quantities have been given, but we have to read in between the lines. Let's start with lambda. Now we are told that the distance between the adjacent maximum and minimum is 1 meter. What do we pick from this information, dear friends? If we consider the traditional waveform that we were given, this is the maximum and this is a minimum. So this is an adjacent maximum and minimum, and this distance was found to be 1 meter. Dear friends, this distance in essence is the equivalence of half a wavelength, dear friends. All right. So with this in mind, we will have that actually wavelength is going to be twice the distance between the adjacent maximum and minimum, which is 1. So this gives us 2 meters. Already we have the wavelength. How about the frequency? Again, from this information that waves hit a beach every 3 seconds. It means after every 3 seconds, a wave hits the beach. After every 3 seconds, a wave hits the beach. It means the time that it takes for one wave to hit the beach is 3 seconds. And this brings to mind period. So period is equal to 3 seconds, which implies that frequency, which is equal to 1 on period, will be equal to 1 all over 3. With this, we have all the elements of our formula, okay? So this means the wave speed is going to be equal to the wavelength, first of all, which is 2, times the frequency, which is 1 over 3. And if you punch your calculator, this should be 667 meters per second. And this is how simple it is. Tomorrow will be better.